All right, let's get started for today. So today we're going to be talking a little bit more about statistical functions. So going a little bit further than just our mean, median, and mode that we've done before. Now we're going to be taking that a little bit further. We're going to be able to create different trend lines and things like that. So before we get started, right, let's do a really quick warm up. This is using concepts from our previous lecture, which was on Thursday for chapter 7. So we had gone over a couple of different scenarios of finding what if. So if I wanted to find, let's say, a specific goal in mind, or if I wanted to see what happens if I change one variable or two variables, we did this using one variable and two variable data tables. We used goal seek and we used the scenario manager for this. So each of them is for a specific purpose. For the given scenario here, right, we're saying that we have a monthly car payment going on, right? And we want to find a calculated payment that's going to not be as high as it usually is. We want Excel to tell us exactly what the purchase price is going to be for our monthly payment to be exactly $400. So this is telling us that we have a specific goal, right? That $400, right? And we want to essentially find what conditions I need to change to get to that $400. So I'm working backwards. That's telling me that I'm going to need to use goal seek because I'm going backwards from my goal of $400. On the other hand, if it was the reverse, and let's say I wanted to see what the monthly payment would be if I had these five different purchase prices, that would be a one variable data table that we're going to be using in that case. So it just depends what our starting information and what our goal is that we want. And we can use the different what if tools to essentially play around with that, right? If it's a single variable we're going to be changing, we want a one variable data table. If it's two variables that we want to change at the same time, for instance, if we wanted to change like a purchase price and a monthly payment or purchase price and a model, let's say, right? We could use a two variable data table. If we're working backwards from a specific goal, we're going to use goal seek. And if we want to be a little bit more thorough and we're using a variety of different changes of variables and we want to keep that more organized, our scenario manager will be our general case. Okay, any questions on our review for the day? Okay. So again, today we're going to be just kind of going through a variety of different statistical functions, creating different charts, things like that. Please keep in mind that with our deadlines, today marks the deadline of week 2 assignments. That's going to include chapters 5, 6, and 7. Haha, 6, 7. So we want to essentially make sure that we're getting through all of this, right? Even though 5, 6, 7, and 8 are all going to be on exam 2. Obviously, I'm not going to have chapter 8 be due tonight because that would be insane. So chapter 8 is going to be due the following Monday along with chapter 9 and chapter 10. So again, make sure you get through 5, 6, and 7. All of that is also, I just posted on Brightspace as well. Secondly, it still shows that a pretty big chunk of the course of the students here are still having unpaid temporary access. Let me just refresh that. Yeah, still 17 with unpaid access. So this is going to be a major issue. You're going to lose your access either today or later this week. It's 2 weeks after you first signed up. So if you haven't already, let me pull up where it was on Brightspace. If you go to my announcements here, I had posted here, important Pearson free trial ending. there's a video here that's going to walk you through how to upgrade your access. You need to be able to upgrade your access to the paid access in order to get the course ID. What I thought was the course ID, this is not that specific course ID that they're prompting you for. Course ID is a paid ID that you only get when you actually upgrade your temporary access. So make sure that you get this done because you will lose your access and you don't want to be trying to scramble around doing your assignments the night before it's due if you don't have access. If you have questions and concerns with this, either stay after class, email us, etc. Make sure you get your access because having 17 of the students here with unpaid access that's not really good. 17 out of the 28 are going to lose their access. So we want to make sure that you gain access for that. Now, what I will say off the record, I'm not going to say this like officially or anything, but there is a way that you can get a refund after the 2 weeks are over. Meaning, if you wanted to, you could, with your free trial, right? It ends now. 2 weeks from now, the course is over. So before it's 2 weeks from now, if you wanted to put a refund in and get back your money, I'm just saying the timing kind of adds up. So I will post kind of more on that later on. I hate to say it, just with how buggy Pearson is, like it's honestly, it's horrible that they're charging that much for like 2 weeks of access at this point. But unfortunately, this is the program that we use with the school. But I do just want you guys to be aware that there is a refund option. I'll look more into that on my own as well. But for now, you will need to pay in order to get access for the time being. So please, 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 please get that done because otherwise you will not be able to do any of your assignments. You will not be able to take your exams. You won't be able to literally do anything. And that's not good at all. All right. Any questions before we move on? Okay. Also, I noticed that there were some issues with one of the projects. For some reason, it is only for PC, only for the Project 5. If you haven't also seen that, this is how to fix the issue if you have a Mac. Just do these steps and email the project to us if you have a Mac and you can't get through Project 5. Otherwise, don't worry about it. If you have further issues, if any of these labs, homeworks, whatever projects are giving you issues and you're doing all the steps, but they're just not giving you your points, email us immediately. We will auto grade it. On the topic of grades, also, all of the grades have been updated as of the moment. If you did the quizzes, your extra credit was applied. Otherwise, it is pretty much where it is at this point. So just make sure, keep submitting your assignments on time. If you don't submit your assignments, it will impact your grade negatively. So you want to make sure, get that stuff in. And I'm hoping that now that I got the hang of how Pearson's grading system works, I will have the grades for the exam and week two's content, likely by Wednesday or Thursday, the very latest, just in case any students have like emergencies and I have to auto manually grade them, etc. Just because I want to make sure that when I sync the grades over, everything saves, and that way you guys actually get the grade that you deserve and not a placeholder 0. All right, with that being said, again, if you have questions, just email us after, talk to us during office hours, whatever you guys need. So we're going to go over our statistical functions today. Okay. So before we get into how we're going to actually use these functions, just a couple of vocabulary. So we're going to be going over descriptive and inferential. Those are two different ways of quantifying data, right? Descriptive is actually going to be describing the data that's there. Inferential is you're going to be making a guess, an inference, analyzing the data. So you're going to be using both of these types of statistics when you're doing these functions, right? Maybe one function is just going to describe what's on the paper, right? Maybe it just calculates an average. Descriptive. Maybe it's going to be more of an inference. It's making a guess for what future statistics would look like. We can do this type of analysis on the population or a sample. The population is the entire piece of data, right? All the students in the class. I could take a smaller sample of that if I want to take maybe only these 5 students or half the class, etc. So sample, think S for small. Most of the functions that we will be dealing with actually do have separate features for the overall population and a smaller sample size. So while they will get very similar results, be mindful of what specifically you are putting into your function, right? Am I putting the entire populated spreadsheet into my function? Make sure you use the population ones. Am I just using a smaller piece of that? Make sure you use the sample ones. These will be labeled with P and S, which we'll see in a little bit to make that a bit simpler. Then we want to, when we analyze these specific pieces of data, right, we want to see how much they vary from the average. This is going to be our variance and standard deviation. So variance is just how varied is my data, right? It's just saying, do I have data that's closer together or is it much further apart? Standard deviation, however, is in relation to the mean, to the average. So oftentimes you might be graded and your grade, maybe you get a curve based on your standard deviation. For instance, if everybody fails, right, that means that everyone's standard deviation is pretty close to the mean, to the average. The average is like a 40, right? That's saying that that now, if the standard deviation is low, right, they're clustered to that 40, right? And based on how the majority do, that tells us how we can essentially do our curve. So both the variance and standard deviation tell a different story about where our results are clustered. And both are going to be used heavily when we're analyzing our data. So this is what I was saying about the P versus the S, right? There's a lot of varieties of the variance and standard deviation formula. Do not worry about memorizing every single iteration of it, all right? The key here is know that there's a standard deviation formula and there's a variance formula. Know the difference between a population and a sample, right? For instance, if I look at standard deviation P, it's of a population, the entire population. If it's S, then it's only going to be of a sample, right? If you're calculating these things, right, it will, on the labs and on the projects, it will prompt you on what to use. It'll say, find the standard deviation of this population. Next, do it on a sample. You will always be prompted. But if you're analyzing data on your own, right, you want to compare and see which of these functions will tell the story that you want best. So it's important to be aware of these, but for the purposes of this class, just really focus on the main gist. We have a standard deviation function. We have a variance function, right? We also have a correlation function, correl. This is going to be showing the correlation or the strength between two variables. So as an example, right, let's take a look at if I were to compare ice cream sales with the temperature. Okay, so we kind of figure out at this point that, well, if the temperature is hotter, ice cream sales should go up. Yeah, that would make sense. So from this data, we can kind of see that as our temperature is going up, Our ice cream sale is 2. That's really great. But sometimes our data is not as clear as this. So we need the correlation function to tell us that. Now, this is a very strong correlation. I plugged in into the corral A2 through A5, the temperature, and B2, B5, the sales, and it outputted 0.98. If the correlation is close to a +1, that's telling me it's a positive correlation. As this goes up, this also goes up. But what if it was negative? If I take a car age and its resale value, we know that as a car gets older and older and older, its value is going to go down. That's what this is showing over here. It's going from 1 year old is 28,000, 2 years old, 25,000, 3 years old, 22, all the way down, down, down to 9.5. This is going to be a negative correlation, right? I plug it in. Now I'm doing the E range and the F range, and now I'm getting minus 0.99. When it's close to -1, that's telling me there is a negative correlation going on. Now, this is pretty easy to see on our own, but if these things were kind of close, right, and I didn't necessarily have as strong of a correlation going on, this number could be smaller and smaller and smaller until it's at exactly 0. No correlation whatsoever. But most things will have at least some correlation. Might not be a strong correlation. It might not be close to positive or -1, but it's a correlation nonetheless. So that is essentially what our Correl function is showing us in that case, right? The other function that we have going on is the frequency function. And the frequency function is going to work a little similar to how VLOOKUP and HLOOKUP and all of those guys kind of worked as well, in the sense that we're going to be creating different bins for our data. So, for instance, if let's say I have all of this high school educator information, right? So all their data, blah, 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 their salaries, what we're analyzing here. We want to find the frequency of each salary. So already pre-made, we have 3 main salary bins, and these can represent our quartiles. We're going to go a little bit more in depth with that, but the key with quartiles is this is what's coming from our box and whisker plots, right? In the sense that I can break up the data to get into the 25th percentile. Right? If you're in the 25th percentile, you're doing better than 25% of the total amount. If you're at the 50th percentile, right, you're right in the middle. You're doing better than 50%, 75 percentile, right? On and on. So our first quartile is going to be our 25th percentile. Our 2 is going to be our 50th percentile, and our 3 is going to be our 75th percentile. We will be going a little bit more in depth with this later on, so don't worry. The key here is, right, we know that we have this data, right? I want to now rake up all of this and put it into these bins and find out, okay, how many people had salaries from 32,668 or less? That's going to be 13 people. Then from 32,000 to 51,000, 12 people. From 51,000 to 63,000, 12 people, right? So we're essentially breaking these guys down into these bins. So as a simpler example, right? Let's say instead I have, here we go. I have some students' exam scores, right? So student A got a 65, student B got a 72, student C got an 88, et cetera, et cetera. We're finding the scores less than or equal to each of these values. So first, starting out, I write in all of my bins. Okay, so I see I have a bin for 70, 80, 90, and 100. Okay, so this first bin, when I put in the frequency function, it's going to find from B2 to B7 all of the scores that are less than or equal to whatever's in this guy. So we know there's two scores that are less than or equal to 70, right? So there's going to be a 60 and a 65. Then I go to my next bin. I go less than or equal to 80. That's going to be one case, right? That's going to be this 72. Then I look, the next bin, less than or equal to 90. That's going to be 2. It's going to be our 82, and it's going to be our 88. Finally, the last possible score is what we call our outlier, a 95. Someone did really good on this exam, right? That goes over here, 1. So it's going to be scores less than or equal to 100. Now, sometimes if you write out the boxes, right, it will automatically generate an outlier value. So if I were to put in, let's say, our 70, our 80, our 90, right? And then what I'm going to just do is I'm going to put in frequency, right? And data array is my first one. So I'm going to drag and get my data. Then I'm going to get the bins themselves, right? That's these guys. If I only have 3 bins this time, right? I have an outlier. Not all my data fits into these bins, right? Because what are these bins? Less than or equal to. 95 is not less than or equal to 90. So because of that, it doesn't fit into a bin at all. This is once again our outlier. Now, if I had 100 here, it would still work the same, but now it's clearly labeled. The same thing would end up working if, let's say, I switch these guys around. Now, as I switch them, these values are going to change, right? Let's say instead I'm going to do 60, right? Already, there's been a major shift. Let's say 75 and let's say 85. Now I know there's one score that's 60 or below, that's exactly 60. There's 2 scores 75 or below. There's 1 score 85 and below, and there's 2 outliers that are greater than 85 that will not fit into this frequency function. So you have to be careful of where you're exactly defining your bins. The one that they used instead, right, over here, this clearly had all of the scores fitting within this, right? There's nothing that's bigger than our 63,000 over here, right? I think the highest score looks like it's about 58,000. So because of that, all of these guys fit in. There is no outlier that we have to worry about. So it's important to keep in mind, like, what specifically are you taking your data into? And finding the quartiles, right, is a great way of kind of automatically making those boxes because you're automatically finding the percentiles of all of these guys. And that's kind of making your life a lot easier because now I don't have to like guess and check in a sense. So similar to where we did with VLOOKUP, HLOOKUP, that kind of stuff, in the sense that it's kind of matching, right? VLOOKUP and HLOOKUP was specifically matching a result to a range, right? This is matching the result to the range, but creating a frequency plot of it. So finding out how many match range 1, how many match range 2, etc. Okay. Let's see, do we have a question going on? Let's finish up the last part of this and then we'll go back to the amplify for the next question. So we did the outliers, right? This time there's an outlier here, right? So our outliers are going to be in here, just like in my example where they were at the bottom part. So again, if the bins are clearly defined and everything fits nicely in the bins, no outlier. If it doesn't, then you got an outlier. Okay. Aside from using the frequency function, right, we can also use the large and small functions, which are kind of a better version of the max and min. So max and min are only going to ever return one argument, the max or the min. What if I want the 3 largest scores? right? I need to have something that can actually return the first largest, the second largest, the third largest, the 10th largest, who knows? That's what our large and small function is. You pass your array in, just like the max or the min, but you also pass in a k parameter. This is going to be the kth largest value. So if I want, let's say, the top three absences, I pass in large, I put my range in, right? F4 through F12, and then H4 is just referring to this one. It's saying, get me my top value. That's the same as using max. But here, I could just define it once, drag and drop, done. Because now for the next one, same range, H5, the second most amount of absences, the third amount. And the same works for our small as well. Okay, let's take a pause for a second. We're going to answer the amplify question. It's like the little matching thing. You might have started already. That's totally fine. We'll go over that, and then we will go on to the... Actually, let's do the two questions. We're going to do question 1 and question 2, which are on slides 4 and 5. So we're good for those two. Yeah. So we're good for this one and this one as well. Alrighty. So first, we got like a little matching going on with statistics. I hope this is gonna work. Um, let's see. Okay. All right. Yeah, I haven't really done this part myself, so I just wanted to try something new going on. All right. The center of a data set is a value in the middle. It represents the typical value for a data set. There are three types, mean, median, and mode. This is going to be measures of central tendency, right? It's kind of right in the name there. We have central tendency, right? And our mean, median, and mode are finding what those center values kind of are. Okay. Then we have over here, let's see, standard deviation, measure of how far the data sample is spread around the mean, right? So our standard deviation is actually based around our mean. On the other hand, our variance, right, is going to just necessarily be in general, like where is our data essentially scattered? Um, okay. I see we have quartile over here, and this is going to be a value used to divide a range of numbers into four equal groups, right? We have first, second, third, fourth quartiles. We can divide them by using the quartiles from a box and whisker plot, etc. It's essentially kind of breaking it down into boxes, right? Then data set containing all the data to evaluate is going to be our population. So population is all the data itself, but a smaller, more manageable part, that's going to be a sample. Okay. Measure of the data set's dispersion. Okay, that's variance. What's hiding behind one of the other definitions? So dispersion of itself is going to be variance, but if we're taking the variance in relationship with the mean, that's our standard deviation. And then finally, we have help define characteristics of population, such as mean, median, mean, standard deviation, and variance. This is going to be our descriptive stats. Is there, oh, analyze differences between groups and relationships between groups of data. That's going to be our inferential. So inferential is analyzing stuff. Descriptive is actual written hard characteristics like mean, median, standard deviation, etc. Okay, so just kind of a little review on those guys. And then finally, which function should you use to calculate the standard deviation, the measure of how far the data is spread around the mean, specifically for a sample data set? Well, we know STD-EV is going to be for standard deviation. Now, there's nothing else that has standard deviation on it, but if there was, right, if we're just saying a sample, right, we know it's going to be the dot S. If it was, let's say, population instead, it would be dot P. So if this was a little bit trickier, right, maybe there could have been an standard deviation dot P, right? And then we want to know the S is for sample, the P is for population. Right, any questions? Okay, we'll get through the rest of the central tendency, take a nice break, go into some charts later. Okay. So aside from finding frequencies, finding the largest and smallest values, what if we want to rank different components, right? Maybe we want to rank a student's grades in the class, find who's the top performer, who's the lowest performer. Well, what we can do is we can use the rank function. Now, there's two types of rank functions here. There's going to be the EQ and there's going to be the average. And these are both for the edge cases where you have ties going on, right? So these are going to work the same exact way for values that don't have a tie. If there's a tie, right? If I use .eq, this is going to omit or just not include the next rank. So if, let's say I had ranks, if I had like 5 people that I was ranking, right? And 2 people got the top score. Okay, so 2 people are going to have the 1 next to their name, but there's not going to be a 2. So it's going to go 1, 1, 3, 4, 5. It's skipping the next rank because there is no 2. We just have a tie going on, and 2 values are going to have the 1 spot. On the other hand, rank.average, right, is going to instead assign an average rank instead. So if we take a look, right, we'll go through these in a little bit. Okay. we have duplicate rankings going on here. We can see both of these guys scored rank 8. There is no rank 9. Rank 9 does not exist because, again, these guys, who should be 8 and who should be 9, they have exactly the same salary. So they're both going to just have 8, and there is no 9. So it's like they're sharing that spot. And maybe this was a three-way tie, a four-way tie, a five-way tie. It would still work the same exact way. So it creates a gap, right? It's like they both have that same thing. They both got 8th place. Now, rank average, on the other hand, is going to instead create an average of the ranks. So instead of saying, okay, you guys are both rank 8, call it a day, it's going to literally say, hey, guess what? You guys are both going to be an average of 8 and 9. It's like having your cake and eating it. It's like, well, you're not really 8 and you're not really 9. Let's make you rank 8.5. Doesn't really make a lot of sense if you're trying to say, like, who got the top score, who has like the highest grade. Maybe you're gonna give out prizes, right? I can't say, oh, you got the 2.5 best score, right? That doesn't make any sense. It's place 1, 2, and 3. So depending on what your specific case is, you want to make sure that you're using the right function for that. So you're going to probably use rank.equal a little bit more. There's also plain old rank as well. But again, you want to make sure that you take into account those edge cases. Now, let's say I want to get, instead of just a numerical rank, like 1, 2, 3, I want to get a percentile of how someone's doing. Maybe I want to say you are like the top scorer, you're in like the 100th percentile or something, right? That's what I can do here. And I can use percent rank dot
Welcome.
inc or dot exc. INC is included, ex
Mm-hmm.
excluded. And the way that this is essentially working, what exactly am I including or excluding? I'm saying, do I want to include the top score as 100% and the lowest score as 0%? So if I take a look, the lowest score is 0%. The top score is 100%. If I want to standardize them just like that, I want to use included because I want to include 0 and 100 as two legit percentages. If I don't want to do that, right? Maybe I don't want to have exactly 0%. Instead, I'm going to use excluded instead. Notice the top score is 8%. The bottom score is 8% and the top score is 92%. Both of these guys are giving me percentage values in relation to the other data, but telling two different stories. So it's all a matter of, do I want it to be in relation to the lowest and the top score being the absolute max and min? Or do I want to essentially say my 0 and my 1 are already established? I'm not using them, right? Instead, I'm going to calculate everything not using those values. So the lowest now is going to be 8%. The highest is going to be 92. And if we take a look, if I add together the lowest and the highest, it gives me 100 back, right? 8 plus 92, 100, 15, 85, 100, 23, 77, 100. Each of them corresponds to each other. So if I take the highest and the lowest, right? The highest is taking 92%. The lowest is taking 8%. Together, right, the highest and the lowest become one whole thing. And I can kind of take it as I continue on, even in the middle two terms, right? 46 and 54, still 100. So these guys with excluded is going to essentially create a combination, right? You don't see that same relationship going on with included. So again, different ways of telling different stories with that. Okay. Going back to quartiles. right? We know them based on the box and whisker plots. Now we're going to actually find what they are. So if we take a look at the previous example with the quartile, right? I had 1, 2, 3. I could have plugged in these formulas into the salary part, right? These numbers aren't just being pulled out of thin air. There's a formula that is calculating the quartile, the first, the second, the third of all of this data. And those formulas are coming from here. And just like before, you got included, you got excluded. Both of them are going to be calculating quartiles. Great. What are we including? What are we excluding? Including includes quartile 0 and quartile 4. Excluded doesn't. So think about what's going on when you have a box and a whisker plot. I think if I draw on the screen, it should probably show. Right? Yeah. All right. I got a box and whisker plot, right? We're going to ignore the whiskers, right? So I have my 50th percentile over here, right? And I have my 25th percentile here, and I have my 75th percentile here, right? So this is like 1, 2, 3. We know it's broken down into those 3 pieces. What if I want to specifically include a quartile 0 and a quartile 4, right? Instead of breaking it down into 3 pieces, right? Now instead, it's going to look something a little bit more like this, right? Before, everything was being crammed into 1, 2, and 3. Maybe I want to spread things out a little bit more. I want things to be shown if they're really, really low and if they're really, really high. So again, maybe I want to show a different range going on, right? Maybe something that would have been a whisker, right? An outlying value. I want actually shown here, right? Because what happens if I have outliers? They just go somewhere in the bottom right corner, right? That's not telling me anything. Well, maybe it is. Maybe that's what you want. But for the most part, right? I don't know what that score could be. I just know it's greater than 85, right? It could be in the 90s. It could be in the hundreds. We don't know. And that could be a problem because, you don't know if you're giving that student an A plus, A minus, B plus. It could be any of those values. It's not specific enough. So for something like that, we want to be careful about which one specifically we are using, right? For the general purposes, the excluded function is the standard. You will be using 1, 2, and 3 for most purposes. That is how a standard box and whisker plot is drawn. You only really use 1, 2, and 3. So the exclusion function is going to essentially be the one that you'll use more often. Included, not really used as much. So if we continue on, right, I can just specify these quartile arguments with whatever one that I want, right? So if I want to get the 0th, if I want to get the first, the second, the third, the fourth, etc., right? Now, interestingly enough, right, 1, 2, and 3, we already went over 25th, 50th, 75th, right? Basic stuff. But the 0th percentile is literally the lowest value. It's equivalent to using the min function. Just like the 4th quartile is the highest value. It's equivalent to using the max function. These are usually your whiskers, your outliers. Because of that, right, you're not really going to be plotting these in a traditional box and whisker plot. You can just use max and min for these guys. You don't necessarily have to calculate it using the quartile argument. That's why quartile excluded is the more popular one. Okay. Can also do this with percentiles as well. So we know that quartile 1 is the 25th percentile, quartile 2 is 50th, quartile 3 is 75th. If I want it in percentiles, I just switch it from quartile.inc or x to percentile. So maybe instead of having just the value itself, I want to have a percentage. So this is saying this salary is in the 8%, 15%, 23%, 31, 46, etc., etc. Right? And we can use conditional formatting to make it look pretty like this if we want. Um, Maybe I want the first quartile to be in orange, the second to be in gray, the third to be in yellow, etc. I can do things all like that, right? And as we could see, whether I use included or excluded gives me very different values, right? If I have quartile excluded, I do not get that 0 and that 4. And the numbers do shift because now, instead of putting all the data into 3 bins, right? I have 4 bins now. It gets spread a lot evener. Just like how I did for the, oops, just like how I did for this example over here, right? If I change the way the bins are, right? Less bins, they get squished together a little more. More bins, they get spread out. Okay. So we went over descriptive versus inferential, right? And we're going to take a short break. Let's come back at 12:10, and then we'll get started on using different analysis functions and the last part of the lecture. You guys can take a break. We'll get back at 12:10. In the meantime, also, if you'd like, I'm going to release the next question, so feel free to answer that. But for the time being, we'll come back at 12:10. Okay, let's get back. So for the next question, when ranking a list of values where tie values exist, which function identifies the rank and assigns an average rank to the identical values? So we know that rank has two functions, .eq and .average. If we want to assign an average rank, we're going to be using the average one, right? .eq would just have the identical values. The percent rank instead would give a percentile instead, right? But this is giving a rank itself. So just a numerical rank. So we want to use rank.average for that. Okay. All right, so I'm going to go a little bit quicker on this section just because this is kind of one of those tool packs that are as an extra um, kind of analysis feature to Excel. So it's not necessarily something that is built into the software, and it's not really something that you'll be using very often. So we're going to just go kind of quick through this. As a result, this part won't be tested. For chapter 8, as I kind of mentioned before, it's going to be mostly the functions we spent more time on. So you're going to have a little bit of time in lab as well to go over it. Um, we'll kind of go over an overview at the very end on what to kind of focus on from this because, again, there's a lot of functions kind of going on, but just focus on the main ones. As I kind of said in my post, a good way of studying, because again, it's open books. You don't have to necessarily worry about memorizing things, right? With Excel, you shouldn't be memorizing things. You want to know how things work and where to find things. That's the most important thing. And that's what I hope that you get out with this class. So I recommend creating a table of all the useful functions, right? And that way, when you're on the exam, you could be like, okay, I have to find different percentiles, or I have to find a quartile, or I have to find this. I have this right on my little sheet, and I know immediately where to find it, can match it up, boom, done, right? Because the exams themselves are more about just recalling specific pieces of information. When you're doing the actual projects, that's when you need to know how the functions work. As long as you have your guide, you know where to find them, and you know how to use them, you can do anything with Excel. So this specific analysis pack is called ANOVA, which is analysis of variance, right? AN, analysis, O, of, VA for variance. This is taking our variance calculations one step further. So similar to what if, right? Where we're kind of finding if I change this, what happens? If I change one variable, what happens? If I change two variables, what happens? Etc. We're doing something similar. We're finding how a single factor or two factors change up in this case. And by using this, I get a really nice table that gives a summary of the counts, the sum, the average, the variance, all these like central tendencies that we've gone over. It also gives you a lot of other really detailed information that you probably would only be really using if you're in like a science major or things like that. So if I were to go onto my Excel, right, and let's say, what was the data I used for this? Um, okay, let's just say this one over here, right? Let's say I take my data over here, right? And I'm gonna go for data uh and analysis tools, right? I want to make sure that this guy is checked on, just like how we checked on solver in order to access this, right? I can go to data analysis. Now, there's a lot of stuff here, right? And most of the stuff we will not be going over. Um, we will go over histogram, and we're going to be doing a little bit of ANOVA. That's what we're on right now. But there's a lot of ways that you can take your descriptive data and take it one step further. You could predict values, you could find the tendencies of your data, all kinds of things like that. Extremely important for things like finance, for things like science, finding trends. So I can choose if I have a single factor, if I have two factors. I just have a single factor, right? I'm just comparing temperature with ice cream sales, right? It's simple as it gets. As the temperature changes, ice cream sales go up, right? We got our independent and dependent variables. So I'm just going to say ANOVA single factor, right? And I have to say my input range, right? So I'm just going to highlight this guy over here. Now I have to specify whether it's grouped by columns or rows. Well, it's grouped by columns in this case, right? Because the first column's temperature, second column is ice cream sales. And pretty much now I could choose to put it on a new worksheet, new workbook. I'm just going to put it on a new worksheet so it appears down here, right? And boom. Just like that, I get all this data just from like clicking like 3 times, basically. So again, this is the stuff that you're probably going to use more. The count, right? I know I can just find this by just using the corresponding count function if I wanted to. I could find the sum easily too. I could find the average. I could even find the variance. All these are functions that we know how to do. But what's nice about ANOVA is that it puts this effortlessly in a nice summary table. More importantly, it calculates all of these factors down here. These are the source of variation, right? So for anyone that is interested in statistics, you might find this kind of interesting, but essentially we're finding a couple of different ratios between our pieces of data that help us find meaning, right? So sum of squares, degrees of freedom, mean square. If you haven't taken statistics, none of this will make sense. Don't worry about it. But just know this is a tool that exists and it lets you calculate this stuff really nice and easy. And you can also do other things too. Like if you had two factor, if you had correlation, covariance, etc., right? Instead of using the function, right, maybe I want to use the correlation function from here instead, right? I can totally do that if I want to, right? I'm just going to go here, data analysis. Let's see correlation, right? And I'm going to take these values here, right? And it gives me a nice little data table like that. And I can even see, right? This is that 0.98. That is the correlation between these guys. We got that same value right here, right? So we know that these guys are indeed correlated. But it goes one step further and it also finds the correlation from column 1 to column 1, and column 2 to column 2, right? We know this is just one because literally column 1 to column 1 is just matching them up. It's saying if you have a 70-degree day, you have a 70-degree day. It's exactly the same. So maybe you have data that you need to pair up and you need to find the correlation between multiple X and multiple Ys. This is a great way to do it. Otherwise, correlation function does the same thing. So your data analysis, great for analyzing data much more deeply. That's as far as we will really go with this for the time being. There's also the histogram function as well. So aside from finding things like the correlation, covariance, and using ANOVA, maybe I want to make a histogram, right? I'll go to my data. Now, I made a histogram over here. I just went to insert, and we know we have a variety of different charts and stuff here, right? I go here, I could do a histogram. I could have either just your standard like columns over here, or maybe I want to have a line going through them, calculating two pieces of data. Maybe as the ice cream sales go up, how is it also affecting not just my sales, but the people at the park? I don't know. Maybe people want to come to the park more if there's ice cream there, right? I could compare multiple things using one of those guys. But what's also cool is I can go back to my data analysis, and I can click the histogram over here. Okay, I put my input in once more, right? And this is going to give me a table version of that histogram. Notice I have bins, I have frequencies. Oh, wow, that sounds very similar to the frequency function that we did. That's all a histogram is showing. A histogram really just is a frequency map. So I can choose to show things in table format, which is great with this data analysis, or I could show things in chart form. Now, picture is always worth 1,000 words, right? Charts are always the kind of more intuitive way of interpreting things, right? So, you always have to just take into account what will better tell my story. Numbers, okay, I see numbers. Chart, oh, I can clearly see that as the temperatures go up, so does the ice cream sales, or whatever I'm essentially trying to show here, right? Maybe this bar chart's not really showing me what I want. Maybe I want to show more of a trend line, right? I want to show as the temperature goes up, ice cream sales also go up. And sometimes things aren't very linear, right? Maybe I want to find a line of best fit to pass through this data. Since this over here is not a perfectly straight line, right? Maybe I have something that looks pretty crazy looking, right? Maybe I have something that's a little bit more zigzaggy, and I want to find that line of best fit that can go through. This is where we're going to get into using trend lines. So trend lines are essentially going to be forecasting, essentially, the trend that's going on. And it allows me to find what values may be in the future based on what I know from the present and the past. So you can do this by going to the forecast feature. However, it's been very buggy on different Excel versions, so don't worry too much about that, right? We can create trend lines easily just by using the charts that we are already familiar with, right? So I already did one for this one. Let me go to a different piece of data here. I'm going to just say my sales for the month, right? This is just another function chart that I have here, right? I have a couple of different measures of central tendencies here. I have like variance, standard deviation, largest, smallest, right? Could plug in any value to get whatever I need, etc. So I'm going to make a trend line. Let's see how this stuff changed over the months. I'll go to insert and I want to go to my lines over here, right? So let's say I just have a simple line graph, right? Okay, cool. I can clearly see that my sales go fluctuating all over the place, right? They increase, decrease, increase, stay pretty stagnant, decrease again, etc., right? But maybe I want to kind of make this into a function. This is definitely not a linear function. It's not a straight line. But I can attempt to make an interpolant or a line that tries to go through as many points as possible. You know it is the line of best fit. If I go to chart design, add chart element, I have trend line. Now, there's a couple of different ones that I can choose. Linear is just a straight line. It's going to just make a line of best fit, right? For something like that, that's not that good. That is kind of missing a lot of points there, right? It tried, but sorry, not that great, right? Maybe I want to try something more exponential, a curve, right? That's looking kind of similarly. We can see that there is a slight curve to it, but unfortunately didn't really hit the mark, right? That's the problem with some of these graphs. If you have data that's all over the place, it's not always going to be the best line of best fit. Now, I could also, instead of doing linear exponential, I can do what's called a linear forecast. This is going to not just have a line of best fit, but it's going to extend it. So it's going to show me a little bit further out, not just at the end of December, but hey, if I had January here, what would that look like? February, March? I could expand this if I want, right? But this allows me to forecast the future. So we don't have to necessarily use the forecast feature on Excel, right? We can just create a line graph, add a chart element, and boom, it's right there. The final one over here is moving average. Now, moving average, that made the best line of all because it changed as it's going along, right? While all these guys are kind of overlapping pretty much to straight lines, this one is curving with the function itself. And the reason for this is because instead of just finding a linear function, right? We know linear is just y equals mx plus b. Instead of finding like a logarithmic or polynomial, right? Moving average is going to be essentially finding pieces of the average. It's going to find the average of these few values, then these few values, then these few values. So it's not just a single average and calling it a day. It's not just a straight line. It's multiple lines. It's like you're building out of Legos, right? You take a piece of a Lego here, one here, and you build up piece by piece. So because of that, you're not dealing with a single straight line that can't bend. You're dealing with multiple bendy pieces, like a bendy straw. So that allows me to essentially bypass having just a line that doesn't pass through a lot of points, right? This data is very zigzaggy. This line tried, but maybe that's not good enough for you. Maybe you need something that fits a little bit closer. Now, with these types of trend lines, what's great about finding a line of best fit, right, is once you have a line, I could find the equation of the line super simple and use that equation to find future values. So I can do that by finding the intercept, right, the y-intercept. I could find the slope, and I could even find other data as well, right? I could find the correlation coefficient. I could find the standard error. These, as you can tell, we don't use as much. Therefore, intercept and slope, those were ones that we would use, right? Any math class that you've been, you probably have the equation of a line drilled into your brain, right? This zigzaggy points, that has like no equation to it. It's just a bunch of points that have no relation, right? Okay, there's correlation. It's going up in an upward trend, but this is not telling us much. We need a line to actually define here. This line has an identity. It has a slope. It has a y-intercept. Once I create that line, I can predict by plugging in any x value, any number of years. Will it be the most accurate? Maybe not. If it's not a good line of best fit, it's not going to be that accurate. Okay. So we did all of this. There's also a function for finding a specific value. So instead of using a line of best fit, if I want to find what, let's say, sales are going to be January of next year, let's say, right? I don't have the sales for that, right? I only have up to December. Instead, what I can do is I can use forecast linear, right? I could take in what specific data I have, right? And find it for a specific day or year or month, etc. So if let's say I have month here and I have sales here, right? Just a simple example. I got all my sales going on. I want to find what it would be in month, let's say 13, right? So if 12 is December, 13 would be like January of 2027 or whatever year we were dealing with. I put that as my first parameter. Then I put my known y's and my known x's, right? So what are my known y's? That's my sales. What are my known x's? Those are my months. Notice that on the function, it is in reverse. But by doing this, it gives me 22.8. That is its estimation of what the sales would be in that month. So behind the hood, Excel's creating that line of best fit, finding the function, the slope, the intercept, all that stuff. And then once it gets the line, plugging in that 13 into that equation and finding out what that value would be. And I could plug in anything I want. I don't know, maybe I'd do 100 and see what happens there, right? We have it increase a lot at that point, right? This, even though here is stagnated, because it's creating a line of best fit, right? That line at the end is just going to be increasing at a certain point. So this is not linear. Linear is not really the best way of approximating something that is very fluctuating. If this was just increasing, yeah, that's practically a straight line as it is. I don't have to worry about that as much. Key here, right? If I want to analyze things for the future, I want to create a trend line. And if I do that, I can use forecast linear to find what specific months or years would give me based on the data that I know. There's a couple of different ways you can do this aside from just linear. Don't worry too much about it. Linear trend is the most well-known, right? Straight line. But maybe I want to use an exponent instead. Maybe it has more of a logarithmic curve to it. It's not necessarily increasing at a constant rate. We have to consider what is my data? What is the trend of my data, right? Analyze the trend line and find the function that works best with that. Because if you have something like that, like stocks, always fluctuating up and down, that is a horrible trend line, right? Okay, maybe it gets the gist of it, the average, but for the most part, it's not going to tell you when you have these peaks and when you have these valleys. Maybe something that would be better is you have something a little more exponential. This is increasing exponentially. This is decreasing exponentially, right? Different functions and trend lines work best for different pieces of data. It is not one size fits all. Okay. And then just going on about the moving average, right? We found the moving average was our best of both worlds in a sense. I go back to over here, right? Our other lines of best fits were just pretty much straight, didn't really tell much of a story. Moving average took the average at each piece. And the way that works is it takes it on perhaps a 3-month window, like how it is here. It finds the average of these 3 months, January, February, March. Then it moves the window down. February, March, April. March, April, May. April, May, June. It's shifting it down and it's finding the average of every single combination that is adjacent to one another. That's why this is much more precise. You are finding the average in pieces. By doing that, you're getting something that tells a much more accurate story. This is still a function, right? Still a function, this curve. It has its own equation and everything, but it's much more precise than a single line. So something like using it for stocks, maybe using a moving average would be a good option for that, right? Maybe you want to be able to kind of um, estimate the peaks and the valleys kind of going on, right? That could be a way you can do that. Or maybe you just want to get the average and you want to use a linear trend line like that. Everything has a different reason for using it. Okay, with that being said, right, moving average, see, it tracks it a lot better, right? It gets your average at each of these values, right? It kind of tackles that peak, all those little valleys. It's much more precise. Okay, with that being said, we're done with the lecture for today. I'm going to open the last couple of questions. Feel free to work on those and head out for the day. If you have questions, let me know. I'm available. But otherwise, I hope that you guys have a wonderful day. And again, for the exam, I'd focus more on functions like just standard deviation, nothing too crazy. You don't have to necessarily know every single iteration of standard deviation or variance. Just know like what is correlation? Uh what is the frequency function? Things like that. Just nice and simple. It's going to be very similar to the previous exam. All multiple choice, a couple matching, none of those crazy fill in the blanks. The midterm study guide should have been posted. Should be under home. Yeah, it's right here regarding midterm 2 and study guide. And I have that right here. You can download that, open it up. And this is pretty much just from chapter 5, 6, 7, and 8, just kind of a gist of things. Again, not all of this will be tested. Don't worry about stuff that we haven't really focused a lot on. Just kind of get the gist of things, right? This is kind of a summary of everything that you would need to really know. And again, you have your notes. If you understand this and you know how these functions work, like, and you can apply it to a question, like, you're good. You can honestly, even if you wanted to, plug this into ChatGPT, ask for sample questions. There was an article in the news that said, like using AI actually can guess pretty accurately what your exam questions end up being. And I'm not even kidding. I honestly use that to study for my own exams. I'll put all my notes into AI and be like, give me sample questions. And chances are it will be quite similar to what is actually going to be tested. So just as a nice little study hack. Otherwise, tomorrow you guys are going to be doing a review during lab. But if you have questions, I don't mind going over some stuff now, or if you guys want to head out, whatever works. Otherwise, tomorrow the exam will be starting at lecture. So 11 a.m. Just be just like last time.
You told me that.
How much does the program cost? I keep getting different values for it, and I'm really hoping that they didn't raise the price, but I saw it was like between like 120 and 130. They give you a year's access to it. And I was really trying to look for something a little bit smaller, but unfortunately, that's the only one that they have. but they do have that whole refund policy, which I'm going to look into a little bit more. So if you purchase it now, I think within 2 weeks you can return it. So you can do your work for 2 weeks and then return it when you get your grade. Um, so I will look into that a little bit more. Again, though, for now, unfortunately, you guys do have to purchase it. I'm really sorry. I honestly thought that it was going to be provided through the school. If I knew earlier, I would have definitely put it in the syllabus and put like a notice about it. So, really sorry about that. Okay, I'm gonna go over the questions really quick. If you guys have any other questions, feel free to ask in the chat. But for the time being, I'm gonna go over the rest of these. So, according to the trendline descriptions, which type of trendline is best utilized to evenly visualize data that fluctuate over time, right? So, we kind of saw a lot of different data that does fluctuate over time, right? Like with the stocks, let's say, right? And we saw moving average was the best way to do that, right? Doing something like this is a way better estimate than something linear. Maybe things would be more linear, like maybe the ice cream example, right? That had a pretty good trend line. Maybe it would be something more polynomial. Maybe you have like a parabola going on, right? Exponential, it's increasing exponentially. But for things that fluctuate a lot, moving average will ensure that it gets all of those peaks and valleys. All right, when using statistical functions to perform trend analysis, which function specifically calculates the point at which the line will cross the y-axis? This is going to be our intercept, our y-intercept, right? If we go back to using the equation of a line, y equals mx plus b. M is our slope, b is our y-intercept, right? So using the intercept is going to get me that y-intercept where I cross the y-axis. Okay, and finally, in the quartile inc function, which argument value should you enter to identify the median value, the 50th percentile? It's going to be right in the middle, quartile 2. So if you're dealing with the EXC, you are only going to have 1, 2, and 3. 2 is going to be the middle, right? If we're dealing with instead, our inc function, right? The only difference is we have 0 and 4. So again, 2 is still going to be in the middle of that, but everything else kind of does get shifted a bit. Okay, with that being said, that is the end. Feel free to ask me any questions. I'll stay on for a bit. And I hope you guys have a great day.
30 minutes.
Hey, I have a couple questions if you have some.
Absolutely. Let me just stop the recording really quick.
Sure.
Like 1:15. I can be there.